All right, so today we're looking at polygons. So as it says there in the first point, a polygon is a straight-sided shape. So really you could have a square that's a polygon, or you can have anything. So even if I did something like that, if all the sides are straight, it's a polygon. Okay, so the difference between a polygon and a regular polygon means all the sides are equal. So if you look, a square is a regular polygon. So if we have a square, because they're all the same length, the sides, and the angles are all equal, so we've got all 90 degrees in there. So, and a equilateral triangle would be a regular polygon. And you're going to hear them, they'll say it's like a regular, they say it's a regular hexagon, so that means like it's a six-sided and they're all the same. So a lot of ours will be regular and they'll say that. And so when we have a regular polygon, the angles are also the same size. So all those angles inside, say that hexagon would be the same side. Now, this fact here is pretty important that you are aware of this. If you have a polygon with n sides can be divided into n triangles. So what we mean by that, if you have, say, a square, it has, so say that's a square, its n equals 4 because it has 4 sides, okay? Now you can divide that, because it's got 4 sides, you could divide this shape into 4 equal triangles. And so what it means is I could divide it there, and there's those 4 equal triangles. So bear with me, if I try to do I'm trying to do a sort of a regular hexagon here. So the regular means they've all got to be, I didn't do it too well there, but a regular hexagon there, 6-sided. So because its n is 6, I can get 6 triangles. So if you see this, you can see I can divide up into 6 triangles. And why is that important is because mainly, like we were talking yesterday, if you've got a full circle, you've got 360 degrees. So if you've got these 4 triangles here, you've got 360 and you divide it by 4, and therefore this top angle is 60 degrees up there. And this one, if you do a full circle around here, you've got 360, but because there's 6 points of the triangle up there, you divide that by 6. Oh my god, that should be 90 up there. What's 360 divided by 4, boys? 90, sorry. So if you divide by 6, you get 60. So we know up in here is 60 degrees. All right, so that's probably important to remember, that you can divide the shape up, and you could know that. All right, but we've got a few new formulas to look at, and we can find the sum of the interior angles. So that would mean if I had a square, I'd be adding up all these. This formula will add all those angles up and give me the number. Now we know there's 360 inside a square. So let's see if this formula, now you're only going to use one part. This is just showing 2 ways. So I suggest just use this part of the formula. So if I did that and I did 180, say this square has 4 sides, it'd be 180 times 4 minus 360. And if you do that, you get 360. Okay? So that is a formula. So for a square, we know, but say for a 7-sided shape, 12-sided shape, we don't know what they're all going to add up to. We'll use this formula. Okay. So it only works if the polygon, if their internal angles are less than 180. So really, you'll see that most of them are going to be regular anyway. But I don't know, if we had a weird shape, don't worry about it. Anyway, So even if this is, see how this is 1, 2, 3, 4, 5. So if I was working out the sum of this shape, because it has 5 sides, it'd be 180 times 5 minus 360. So all the angles inside that triangle is, if we work it out, sorry, so 180 times 5 minus 360 is 540. Okay, so if I added up all these angles, I'd get 540. Okay, so that's the interior. Then there's also a formula. That's for the sum of all of them. But there's also a formula if you just want to find one if it's a regular. So say I'll use this hexagon example again. So if I wanted to find one interior angle, which would be here in between, say there, what I can do is I can do the formula, which is 180 times 6 minus 360 divided by 6, because a hexagon has 6 sides. So if we did that on the, we just do that on the calculator, and I get 120. So that angle in there of a hexagon, so if I had a hexagon, a regular one, which means all the sides are the same, I know that this angle in here is 120. I can work that out using this interior formula. Right, so if I get just given a question, so this was the question, find the sum of the interior angles of an 8-sided convex polygon or an octagon. So really n is 8. So I've written out the sum formula. I'm actually going to rub this bit out so that we don't get confused. So I'm just going to use this bit. So the sum will equal 180 times 8 minus 360. So if you do that, we get the sum of all the angles inside of an octagon are going to add up to 1080 degrees. Okay, so there's that. Now we can also talk about the exterior angle of polygons. So if you add the sum of the exterior angles, so exterior angles are when you continue the line a bit more. So we looked at that yesterday, and we saw when we saw the triangle continuing on, and we said, say that guy plus that one, plus this one, if I call that Z, they equaled 360. So it's the same with any polygon. If you keep extending the sides out, that external will add up to 360. All right, so if you have to find just one exterior angle, so say here we just wanted to find what A is, it's going to be 360 divided by, now this is a 5-sided shape, so n equals 5. So if I was just finding A would equal 360 divided by 5, which equals 72. Okay, so I know that's 72 degrees in there. All right, so have a look at this. So just to explain, so an interior angle is the one inside here, and that's the formula there, and the exterior angle is that one when you extend the side of the shape out like that, then we can find that one. As I said, they're not really going to ask you to define it. They're just little pieces of your puzzle that you can do. So here is just that, and just down here is that little fact they're talking about, that for a regular polygon, you can divide it into the amount of triangles. So say this pentagon, because I think it's 5, can be divided into 5 equal triangles, just so that you know that. And as I said, they're doing that so that you can tell me, you can work out those top angles. So let's do a couple of questions. So here it says the exam question. It's asking us for find the size of the obtuse angle FOD. So when they do that, they want FOD. So this is the question in there. But if you have a look, this is, they would have told us, and they did. They said it's a regular hexagon. So because it's a hexagon, I could break it into 6 equal triangles. So, and I'm saying around here would be 360. So all these little tips of those triangles will be 360 divided by 6, which equals 60. So if one of them is 60, you can see I have 2 of them here. I've got one here and one here. So the angle, sometimes they write it like that, FOD would equal 120 because it's got 2 of those in there. Okay. The next question was, what is the interior angle of a 16-sided polygon? So pretty much just need to know that n is 16. And so I've just copied down the interior formula. So I just simply do that on the calculator and get my answer. You know, you guys can work that out. And what is the size of an interior angle if it of an n-sided regular polygon is that? So what they've told you is they've used this formula, but they've told you what it actually equals, and you're trying to find n. So all I have to do is go 165.6, and I'm going to write equals that formula, like so, and I can just use my solve function on the calculator. So if I do that on the calculator, which I'll do, menu 3.1, equals 180 times n minus 360 divide by, oops, oh my god, sorry, and I get n equals 25. So it's a 25-sided shape. All right, so there's how we can do the other way. All right, this one was actually taken from an exam, but you can see it's exam 1, so it's gonna, question 1, it'll be very easy. So if it says a wheel has 5 spokes equally spaced around a central hub, as shown in the diagram, the angle between the 2 spokes labeled on the diagram, what is the angle? So you've got 1, 2, 3, 4, 5, and you've got 360 there. So 360 divided by 5 would give us the angle, so we get 72. Okay, really easy. Okay, here's another one. It says a 6-pointed star is a popular patchwork pattern made by sewing together 6 flat rhombuses as shown. So a rhombus is, and you might have to have these on your summary sheet. So when you have a rhombus, it's like the diamond shape where these opposite angles are equal. Okay, so they still add up to 360, but it's not quite a square because you can see sometimes the opposite angles are equal, not all 4 are the same. So it's shown here, and they want us to find this angle out here. So if you have a look, if I'm looking at this rhombus in there, and I'm going to work out what that angle is, that purple one, because then I've got 2 of those purple ones there, and then the whole circle. So if I had the purple plus that angle, that's going to give me 360. So if I can work out what that purple one is. So what I did is up in the center of this star, I've divided, there was 6, 1, 2, 3, 4, 5, 6. So this angle up here is 60. So I knew that that part of my rhombus is 60. So because it's a 4-sided shape, it will have to all add up to 360. So if I've got 60 on each end, then I've still got 240 left, and that's how I get this 120. So now I know up here is 120, 120. So this black bit must be 3, and also 120, because it's got to add up to 360. So I know the angle equals 120 degrees. So there's a few ways to find it. Here, over on this other one, you need to just sort of see this as a straight line, which adds up to 180 degrees. And because these shapes are all equal, this angle would all be the same. So if I do 180 divide by 5, we get, what do we get? 36 degrees. Okay, so then I know that that angle equals 36. All right, here's another question from an exam. So it's question 4. So getting a little bit into it, but as I said, they'll tell you it's a regular, meaning that all these sides are the same length. Okay, and it's divided into 3 equal parts in the diagram shown below. So because those parts are all equal, they look like a rhombus to me. So we need to find the angle of this one. But because it's a rhombus, that would also be the same. And then these two would be the same. So if you can see, I've got a full circle in here. So if I do 360, because there's 3 of the same angles there, divide by 3, I get 120. So I know that this guy in here is 120. So then that makes this one 120. So that's 240. And we've still got 120 left, because remembering a rhombus is a 4-sided shape, which would have to add up to 360. So if this guy's 120, this is 120, these ones are going to be the same size, so they'll have to be 60. So we can work that out. Okay, so that's that one.